And we're about time. Okay. So for those of you that are heading for Black Widow, this is Black Panther. There was a previous speaker here setting up. We've got us in the right rooms. So today we're talking about asynchronous JavaScript living on a prayer. This talk covers a lot of the boundaries of the browsers that I've come across over the years. I had been poking at it a few years back and broke my browser a number of times with some of my testing. And it kind of made sense to make it into a talk. There's a lot of things that happen in your browser you don't expect. Many of us have learned what some of those are, but it goes further than just handing off to a queuing tool. At its core, JavaScript is a synchronous language. It can only do one thing at a time. It's running on one thread in your browser. It cannot do multiple things at once. Those of you that have written that infinite loop, I've done it a few times, right? And your browser just stops. And it's not as bad these days as it used to be, but it used to be really, really bad when you would lock it up. I mean, you'd have to shut the browser down, hardcore shut it down, change your code, bring it back up. JavaScript is an asynchronous language, which means that it can behave asynchronously. So we can interact with unexpected events like a mouse moving on the screen or a click event. Okay, your code doesn't know when that's going to happen. So we're looking at user interaction, network activity, disk interaction, inter-process communication, timers, and a few more things. Okay. And I'll get my mouse back on the right screen. Here we go. I'll be turning around a lot because we'll have code up here. About me, I've been writing code since I was 10, so 47 years at this point. I'm a husband, father of two. My wife will be here later tonight, so those of you hanging around me, you'll meet Jen. Work at Leading Edge. Been there 8 years now. Enjoy it, love it. I got a slide at the end about Leading Edge. We'll talk about that. I also run Code Squid and Job Squid. Feel free to check those out anytime if you want. That's all the pitch you're getting on those. There's my contact information. Feel free to track me down if you want more. And here we go. So some definitions: parallelism, multi-threaded processes, scheduling things at the same time. Okay. Asynchronous, single-threaded with an event loop. All right, the event loop is a little more complicated than that. There's some really nice tools to show the event loop online. I'm not going to dig into that depth on that one. But we manage with what we call cooperative concurrency. Higher level tasks that concur at the same time. Code is in the queue, and the code in the queue itself, has some level of control of what happens. We'll see something on that later. Okay. What we hope for is contention, that multiple things occur at the same time. Doesn't always work. Sometimes there are collisions, but it works pretty well. And it's smoothed out much in the last couple of years. It's smoothed out quite a bit in the last couple of years. So, JavaScript engine details. Here's an interesting list that's not a part of JavaScript. Set, timeout, event loop, web APIs, message queuing, task queuing. Okay, it's kind of hard to see the crowd, and I know people are in other rooms. But how many have used set timeout? Right, you're writing it in your editor, right? It's feels like it's part of JavaScript, right? It's not, and we're going to prove this here as we go through this. So, one of the first things that came out that really helped with a lot of the asynchronous activity, we had callbacks, and then following that, promises came out, and promises were really good. They really helped a lot. Okay. I've written some really complex ones, and they get deeper and deeper and deeper on the nesting, and it gets really fun to track what's happening when and where and why, right? And this definition of pyramid of doom came out, because it really is. You know, you're turning this thing sideways, and it gets to be a nightmare to read, okay? And the problem is we invert control, okay? When your code is running and doing things, it has control. When you pass it off as a promise, that promise then has a control because we don't know when or if it's going to complete properly. It's really interesting, okay? And it becomes hard to reason about, okay? Because you're thinking about this non-linearly, right? I'm sending off an API call. At some point, hopefully within 30 seconds, it comes back, right? I don't know when. I hand off control. I'm expecting something to happen on the other side. I don't quite know what. We have to coordinate data. One of the fun ones that we always run across is you're typing something in and it's pulling up this list, right? And it filters that list down based on what you're typing in, and it's making calls to the back end, and you don't want to call every character. And so maybe you, as you type 20 characters, you make 3 or 4 calls to the back end to get your update that list. Which one finishes first? I don't know. It's kind of a scary one, right? So that coordination of data, and then things like splitting callbacks, separating out success and error, which is what Promise did for us really nicely, okay? And, you know, a lot of weird things happening there. So after taking a look at some of these definitions, some of the things that we were concerned about, here's what we're going to cover. Quickly, because I've already burned 5 minutes, we're going to do a thought exercise. And the thought exercise basically to show you what we're going to do over here on the right side. I'm not just showing that for fun at the moment. Well, I am kind of at the moment. We're going to go through some synchronous code, non-asynchronous code, simple network code, complex network code. We're going to take a look at some simple promises, complex promises. And yes, there's a next page, and this is why I have to start moving faster. Because we're also going to look at generator throttling, user interactions, event listeners, web workers, timing code, yeah, race conditions. That's the one that quite often will not do what I expect during the talk. Set timeout timer and async await. Now, think about all these activities we're looking at. The chances of breaking something are really high, so it is possible we're going to have to reload this thing. I'm driving the camera nuts walking back and forth. I see it twitching out of the corner of my eye. All right, so a thought exercise. Okay. Here's the fun part, because I got to kind of read some of this look a little bit. So you get to see the back of my head. So almost all my code is going to be based the same way here. I had to find a way to show a set of code that we could run actively, that you guys can actually see it run. But then the fun part is I started to put this out, and I'm like, oh, I'll just console log out what the code is. And then I ran into this, if I do more than 5 lines of code, it puts an ellipses in, and you can't see the rest of the code. Well, it's not very useful. In fact, you can't click the ellipse and open it up. It shortens it. So I had to limit it down to 5 lines. So in almost all these exercises, where we're starting is going to be on the bottom. Start. We just kind of have to follow the path up to figure out what we're doing here. So if we look at this one, in our thought exercise, I'm going to ask you guys what you think is going to happen. We have a button that we're grabbing on the screen that's not on the screen yet. It'll show up because we're going to remove the hide, and we're going to attach a click event. Okay. So if we look at the event, we're going to change a color, we're going to change a layout, and we're going to trigger a wait. Changing the color, no big deal. We're changing the color of the entire box. Sorry, change color up at the top. Sorry, we're changing the background color. Changing the layout, we're adding a thought exercise paragraph tag to the DOM. And then we have a wait. This wait's interesting, and we're going to see it a little later too. It essentially is creating a thread lock. Okay? So the question is, what do you think the code's going to do? Well, the first thing it's going to do as I run the code is it's going to put a button on the screen. Okay, so if I get my mouse over there, this is the really fun part. There we go. Split screen's great until it's 40 feet tall. So what do we think it's going to do? I'm going to make you guys think in this talk. Other rooms, I apologize. I can only hear one room. Change color. I heard change color. Change color. Okay, what else? We know we're adding a paragraph tag. Okay. We have a time up at the top, 5 seconds. So I'm going to click because I don't want to go too long. Okay. I'm going to click this, and we're going to see what happens. And I've clicked, and hopefully it triggered. Maybe not. Sometimes that first time it doesn't catch it. Let's try it again. There we go. So what happened? Oh boy, red is really off on that screen. That literally is bright red. It's obnoxiously bright red. Okay, what happened? The thread lock. Okay, that while loop was running in JavaScript. So nothing else could happen, even though the other activities were started, that thread lock caught us. Okay, it could not update the DOM completely until the thread lock cleared. Okay, not really worried about this code so much as what's happening and understanding how that's going to work as we look at the rest of these exercises. So let's take a look at non-asynchronous code. And we have we're not going to use the debug start. The debugger's changed. We do have debugger in there that you can run in the code. There used to be an option for turning on the debug of async within the console space, and it's no longer there. It's now always on. Okay, so you sometimes in the console, if you're consoling, you'll see it say in there that this is an asynchronous activity and it doesn't know where it came from. That's what you're talking about there. We can start this. This is the non-async. So we're going to follow that start path where we're not async, and we're going to run the sync. So if we look up here, we have a run sync with the console log start. We're doing a for each where we're console logging the number times 2, and we have the end. And if we look up at the very top, we have numbers that are 1, 2, 3, and the for each sync up just below numbers is just essentially firing a callback inside a for loop. Okay, so this is not synchronous. So, as I did previously, what do we think is going to happen? We have 5 things that are going to come up on the screen in the console. Start, the end, and 2, 4, 6, right? Thoughts on order? Quiet group today. Is it that early in the morning? All right, well, let's run it and see what happens. We can talk about why. All right, so let's run the non-async. Oh, I can read that easy. The start, 2, 4, 6, the end. It's not synchronous. There's nothing in there that causes that to operate out of order. Okay? But if we go back to our core code, we have a second loop through, the else, that we can run with async true. That's going to use the for each async just above that, and then the second function down is the for each async that has a set timeout in it. Now here's the fun part. Look at the time on the set timeout, 0 milliseconds. Right? Quite a few of you have written a set timeout. I saw the hands come up earlier, so you put a time in there after the function. Yes? You've done it, yes. Okay. Sorry, second hand went up, threw me off a little bit. What do we think we're going to get with a 0 millisecond set timeout? Nothing. Well, that might be interesting. We have the start, the end, 2, 4, 6. What order? Get the numbers at the end. Sure, let's try it. Running it asynchronously. The start, the end, 2, 4, 6. Now, as a developer, having written set timeout prior to doing this talk, many, many, many times I would have said the start, 2, 4, 6, the end, because I have a 0 millisecond set timeout. Set timeout has to pass that off to the event queue, even with 0 milliseconds. There is a default, I found out. We're going to take a look at that later. It's interesting, because it's never 0. So let's take a look at a simple network code. Whoa, this is a really simple network code. We have a start. We're starting to see the pattern here. Ooh, I hear that echo now when I coughed. Sorry. Console log start at the end. We have the network request. It has a set timeout with the async code after, and the time is now 5 seconds. What do we think is going to happen here? After the previous one, this should be easy. Right? The start, the end, and then the text after 5 seconds, right? So let's start this one, and we see the start, the end, and I'm going to talk for a few seconds as we watch this run, because hopefully at 5 seconds it's going to say, hey, code after 5 seconds. I used to have that at 10. Boy, it's hard to juggle for 10 seconds. Okay? We have this time, which is the 5 seconds, so it makes sense that it handed off to the queue. Right? And the queue somewhere in there said, hey, I got something that you can use, JavaScript. Okay? Now, let's take this to the next step and go more complex. We've got a 1 and a 5 wrapped around a first, and the first fires a set timeout that does a 2 and a 4 wrapped around a second. That second does a set timeout that's wrapped around 3. So we have 1, 2, 3, 4, 5. What do we think the order will be? They do get more exciting. I know people are meandering in and out. They do get more exciting than these. I'm going to guess we're going to see 1 and 5 first. Okay, we do have a 0 millisecond time. We're going to probably see 2 and 4, and then 3 at the end of that. Maybe. Let's see what happens. 1, 5, 2, 4, 3. That final set timeout got put on the queue after the first set timeout came off the queue. Okay. This is where, you know, that if you wrote this as 1, that nesting in there would have been really ugly and fun to follow. Okay, so let's take a look at promises. Promises are a really cool thing that came out, right? When promises came out, we saw some interesting things. I talked about the inversion of control. Promise is a trust. Okay, promise resolves one time. It's either success or failure. Okay, there are no other options. Messages are kept through the chain in there. Any exception becomes an error. And once it's resolved one way or the other, the data is immutable at that point. Okay. Nesting, passing failures, handling failure, passing values, all this becomes really interesting. And let's take a look at code here on this one and see what we're going to do. Well, we have a start and the end. We have a timeout, which we've now seen timeout a few times. And we have a promise that fires in there too. So let's look at our timeout. That looks pretty familiar. Timeout fired. And then we have a promise set to resolve or reject. And it's going to either console log on a then or on the catch, one of the two. So what do we think is going to happen? Well, let's run it and see. The start at the end, we expected that because it passed off both the set timeout and the promise to the queue. Now we console logged resolved before the set timeout. This was an interesting one. I saw this and I'm like, what is going on? Right? Gotta watch my time. This is where I learned that queue that we handed off to, the event queue, has some control and can prioritize. It prioritizes promises over set timeout. Well, that's kind of interesting, right? Kind of a good one to learn. Now we get into complex code here. Yeah, a little longer. We have a set timeout, a promise 1 and a promise 2. Promise 1 is kind of what we saw last time. Promise 2 resolves 2. And inside it runs a promise 3. Let's see what we get here. Start, the end, resolved 1, 2, 3. All of the promises finish before the set timeout. We could extend that, run dozens of them. The set timeout is always the lower priority. Okay? Interesting one to figure out. Now here's a fun one, generator. Generators are kind of cool. How many do back-end work as well? A few. Okay, so you're probably much more familiar with generators than most of the front-end folks. Okay, when I came across generators on the front end, I decided to do some research, decided to find out what they were about. In fact, this slide deck is a generator. The actual slides themselves are what we're iterating over. I was really struggling to find a good use case at the front end for generators. But generators are kind of cool, okay? This is cooperative concurrency versus preemptive concurrency. It's essentially a state machine, okay, at its simplest. Generator returns an iterator, right? Iterator is something we can loop over, we can step through. And wrote an article on it years and years and years ago, and a couple weeks ago, I had a young lady in Africa give me a call. She goes to a Women in Tech thing every weekend, and apparently they used my article to do their weekend training on generators. I had no clue it went that far, but that was kind of cool to see. All right, so what are we doing here? We've got to start, and this initiates the throttle. Okay, it's going to throttle for 3 seconds. All right, we have to initiate it. So that next one, you see the thr.next, that's the initialization of it. Okay, you have to fire it the next at least one time. And then we have that weird code up there, the throttle func with a star in front of it. Okay, it's a really weird setup. But what are we doing in here? Okay, we are executing a throttle function that's passing an argument. We're clearing the timeout if that function runs, and then setting a new set timeout in there. Okay, and then it's running the throttle yield on the while true. And it's interesting. So what's going to happen? What happens is I'm going to start this, and I've got a button in here that's tied to triggering that throttle, triggering the thr next. Okay, and each time I do it, it's going to iterate over that click, and it's only going to console one time. That's the interesting part. Okay, but oh, look, I told you it breaks every once in a while. Let's see, let's try and restart. There we go. Maybe I didn't get the start quite in there. There we go. So I can click as many times as I want, but it's when I stop clicking that the 3-second timer will trigger and start and send a comment one time. Okay, throttle. Okay, not the way I would normally write a throttle. I was actually talking with a gentleman in right before the previous talk, and he was doing something similar with a generator, using it as a throttle, and it didn't work quite the way they expected. Would not be my preferred way to use a throttle, but it's interesting it's in there, handling that async activity. Now this is going to be a fun one. This is my drag and drop. I got to get my mouse over there and do a drag and drop. Okay, so what are we doing? We're essentially setting up a drag over, drag start, dragged up, and this is one of those fun ones because it's going to console like crazy. Okay, which tells us something else. But user interactive code, right? All of these are going to continue to fire with user interaction that we normally can't control exactly how it's going to work. There we go. Grab it and drag. Come on. There we go. And you see it. It's firing like crazy, right? And triggers the drop off that initial code. Okay, I'm going to come back over here real quick and show the code. Pull that back up. There we go. But as I did this, something else popped into my head. How often, when you're thread locked, does the console lock up? Right? This is an interesting thought. Console, all of console is not a part of JavaScript. It's its own API in the browser. It's like set timeout. Okay, so what's next here? We got, event listeners. This is when I hit event listeners, I'm like, okay, event listeners, right? User interaction, this is stuff we're talking about all the time here. So what do we have in code? Event listener, we're getting the element, we're setting up our listener, we're triggering our listener. Okay, I don't have to do anything, cool. We have the trigger listener that does a set timeout to start at the end, and there's a click in the middle of it. Then we have the setup of the listeners that sets up actually 2 listeners are added. Okay, and the output we're console logging. Okay, click enter 1, click enter 2. Now, based on what we've done so far, what would we expect? I would expect the start, the end, click handler 1, click handler 2. That's what I wrote this, that's what I would have expected. But I didn't get what I expected. Okay? Because I had to do some digging to figure this out. The event handler is not asynchronous. It's not a part of the browser. It actually is a part of JavaScript. So it fires synchronously. This was a surprise for me. I really had to go back to specs and figure that one out. How many have heard of web workers? Okay. Maybe 10%. Not bad. Other rooms, I hope lots of hands went up. Okay. Web workers. Web workers are this little background tool that you can use. Okay. And by default, you can find documentation on web workers that basically they have their own thread. You can pass activity off to them. They often can function as man in the middle. Okay. The New York Times used to, I don't know if they still do, have their web worker set up that if you're offline, because it's man in the middle, right? They pass all the data through and back when you're reading the New York Times. And if you're offline, this worked really well for folks that are on trains and things like that in New York City. When you're offline, they got a crossword puzzle. Because it had that stored, ready to go. Okay, so each time it connected, it would get the day's crossword puzzle and stash it. It's its own thread, okay? And looking at the synchronous code, this is a pattern that I've done a few times. All right, so we're looking at the run sync, we're looking at the inline progress is getting that bar, Okay, and it's running the crunch number inline, and the crunch number inline is essentially stepping through, and every second it's going to try and update the percentage. And this is one I've done many, many, many times, trying to show status, and interesting things happen. Okay, this is again, we see the console firing. We're thread locked though, until we get to the end of the 10 seconds. And all of a sudden, hey, look at that, our status bar updates. I've done that many, many, many times. It's not much fun. Okay, with the asynchronous code, we're actually using a web worker in the background, give you a rough idea what we're doing there. Basically the same thing, except we're sending a message from the web worker. It's running that same while loop in that background thread. And it's still able to send the message. So what happens here is as we see our counter increment, our web worker increments. Our JavaScript in its own thread is not thread locked because the web worker's on its own thread. It's kind of an interesting thing to see. Okay, oh, and I often get the question, we'll preempt that question, how many can I have, right? Because you hand off you can do multiple threads. Each browser's different. The average seems to be about 20. You can increment that number. It will slow things down in your browser quite a bit. Oh, this is the one that often breaks on me, and today it worked. Okay, I'm assuming most of us heard race conditions, right? Two things happening right around the same time. Okay, what I've set up here is a basic race condition. When the slide deck is loaded, I have code that's running in the head and code that's running in the body below the DOM elements, right? Many of us that are front-end developers know that you put your code at the end of the body because all the DOM elements are then in place to be able to capture things and do things with things on the DOM. What I've done here is the first one triggers before the DOM's there, before the elements are in place to capture. Race condition here, okay? Simple. I'm going quick. Set timeout handler. This was an interesting one. This is where what I wanted to do is I wanted to test how fast these actually come back. So I'm going to start this timer here because it takes a few seconds as I talk. And what I'm doing is essentially I'm running about 1,000 set timeouts in a row to see how long it takes for these to come back and get the average. The average is 4.54. That's actually a little slow. I usually see about 4.3. It is always, on every machine I run it on, run at 4. Okay, just a little over. And I'm going to run the 10-second one 10 millisecond one while I do this. It's never 0. When I run the 10 millisecond, we're going to be much closer to the 10. It takes a little longer, but we don't have that 4 millisecond gap in between. And I gave this talk at a meetup a while back, and I had some young man in the back who was banging furiously on his computer who came up and said, hey, and I lost the link. I found in the specs that the default is supposed to be 4 milliseconds. Not every browser's 4. There's one or two that are 10 milliseconds, but we're getting closer. Okay, so when it runs, the actual minimum is 4 milliseconds, or should be. Okay, so when we ran that 10, we got closer because we were past the 4 already. Okay. Async await. So, async await is a wrapper for promises. Makes the code infinitely easier to read. Okay, it just wraps and unwraps that promise for us. Okay, that's all it's really doing. So if we look at this, on our start, we've got a resolve state, console log, start and end. We're running the async await. And then our async await, we're trying to do a console log of the await async process, and if we have an error, we'll catch the error. And then in the async process, we've got this really ugly promise up there that has a set timeout in it that resolves or rejects. 2 seconds on our time frame. Success doing something here after 2 or failed after 2. So what do we think we're going to get? What should we get? Start the end and either the success or failure, right? So what we should get, I just want you to see it's a little easier to manage. Start the end, we got the 2 second gap. Hey, we succeeded. Rejection works basically the same way. The start, the end, 2 seconds failed. Okay. So, I think I got through it in a reasonable amount of time. Oh, that's not my watch. There we go. We took a look at synchronous, asynchronous, code using callbacks. We didn't look deeply at debugging. It really has not been a major problem recently. We looked at promises and chaining. We looked at generator throttling. We looked at user interaction, event listeners, web workers, load timeout, and async await. And I told you at the beginning, my organization asked me to put a slide in, and putting a slide into this custom deck is a pain, so it ended up at the end and not at the beginning. Okay, so at Leading Edge, we are a technology consultancy and services company. We're more than just technology implementers. I got to learn to say this really fast. We're a team of strategists, innovators, architects, designers, and engineers who craft thoughtful, impactful, enterprise-aligned technology solutions that move your business forward. Okay, the phrase that they said a while back that I really liked was that we are positive disruptors, right? We disrupt things. You know, you have people in your organizations that come in and help make things change, and some are for the better and some are not. We do it on the positive side, okay? So that's all you're going to get about my company. Do we have any questions? Again, really quiet group. All right, guys, that's all I got. All right.